This conference will now be recorded.
So hi friends. So in the last class, so we covered the like what are the interfaces are available in the collections framework. So we covered in the last video. Now, so in this video, so we are going to see some of the abstract classes and the concrete classes, so that so we can aware of it how the collection framework was developed. Once we complete the classes information, so we can develop using the these collection framework classes. So let's begin the classes information. Collection framework. So collection framework, right? So this is our main heading. So in that we are writing the classes information. So the first class is we have some abstract classes and some concrete classes, and the concrete classes means here we can call it as the implementation classes. So some abstract classes. What are the abstract classes here? It is abstract collection. So what is the class? Abstract collection. So this is the main class. This is implemented from collection interface. So this is the main class abstract collection. So abstract collection. It is an abstract class. So this is implemented from collection interface. So so this class needs to extend from some concrete classes, or we can call it as some implementation class, right? So once we implement from interface, so what is happened here? So what is happened? So whatever the methods are available in the collection interface, those methods are available in a concrete class. So abstract collection. So right. So those methods are available in the collection interface. Those methods are available logically to the abstract collection. Now, so what is the implementation class for one interface and one abstract class? So we need a one implementation class. So otherwise, so what is happening? So these are the declare methods are available in these classes. This class having the still declare method, not implementation of method, right? So if we see the implementation of method, if we want to know the where exactly the implementation of method is available, so those is some of the concrete class. What is the concrete class here? It is ArrayList. ArrayList is the concrete class, or we can call it as the implementation class for this abstract collection and collection. So like we have a one more class called abstract queue. Abstract queue. So this is the abstract class. So by seeing the name of the class name, we can observe it is the concrete or implementation class, or it is a abstract class, right? So seeing the queue class, it is an abstract class. So like we have some abstract classes, and first we will see the abstract classes, right? So that we can aware of, we will not get into some like conflict here, right? So the third one is abstract sequential list. So abstract sequential list is one more abstract class, and abstract set, abstract set. So so these are the what we can call it as abstract classes. So remove the array list because it is not an abstract class. So these abstract collection and abstract queue and abstract sequential list and abstract sets. So how many? So these four are the abstract classes. Now we will see the so these four classes implemented from main is the collection, and we have some sub implementation. So we will see each and every implementation. We will see, and first we will see the some implementation class. So here the first implementation class is ArrayList. As we miss one more thing, abstract list we miss. So this is also one abstract class. So we must the abstract list information. So now we have a implementation class. So this is the implementation class, right? ArrayList, and this class is extended from abstract list. Extends so extend abstract list. So the abstract list extend from. So this abstract list extend from abstract collection. Abstract. So this abstract class is extended or implemented. So first see the hierarchy. So main collection class. So what I'm writing C1. So it is the main. It's a collection. Sorry, it is an interface. Collection is a interface. Now here what's happened? Abstract collection. So this is the abstract collection. ABC I'm writing. Abstract collection is an abstract class. So this abstract class, one more we have a class. So what is here? Abstract list. So this abstract list extended from this is a array list. AL. So this is the concrete class. So this is the hierarchy of the implementation array list. See the hierarchy how it is. So for each class we have some different hierarchy. Like so see this is the interface and this abstract class, and one more we have abstract class, and here it is in concrete class. So for all methods is implemented in array list. So if you see the specific class, we have a different implementation of these methods. We have a different implementation of collection interface. So in that I miss one more thing. We have a list interface, right? So in the list we have some specific method, right? So where exactly the here it needs, here it is a list interface. So see the magic here. Abstract is extended from collection. Abstract collection is implemented from collection, but abstract is extended from abstract collection as well as implements from list interface. So in array list we have a different implementation of listing. What's the list interface having the methods, and whereas the collection. So see, it's very important if we know the hierarchy of the any class, so it is easy to develop the any program. Now we have an idea. So in the list we have a add method. It's specifying the index number and the object. Like add all index number and the collection object, and remove the index number and the object. So like we have some specific indexes. So this is the hierarchy of the array list. Now we will see one more one. Now, but we will write each class. So array list extend abstract list. So where is abstract list? So abstract collection and implements, right? Implements list interface. So this is the so main structure. It's completed array list, and we will see the array list. What is the purpose they develop the array list? So as of now, just get the hierarchy, and one more implementation class is linked list. So one more implementation class is linked list. So this linked list so implements a this linked list implements a so this linked list first not implementing, it's extending, extends from abstract sequential list. Abstract sequential list. So this linked list extends from abstract sequential list. So abstract sequential list is extended or implemented. So this extended from abstract list. This extended from abstract list. And if you see the abstract list, so where is our abstract list? So right, this is our abstract list, right? So see the sum here different. Like you have one more. So we will see here two more steps extra. We will see because first this is abstract collection list, right? So after that, so this abstract list extend abstract collection implement list. So this abstract collection list again is extended abstract sequential list. So again is extended in linked list. So what is the hierarchy here? What is the hierarchy? Collection is top of the interface, and here it is an abstract collection. Abstract collection is an abstract class. So after that, so what is here? What is here? Abstract list. What is here? Abstract list. So here abstract list, and here we have a list interface. Here we have a list interface. Now the abstract list again extended here. Abstract sequential list. Abstract sequential list. So abstract sequential list, one more abstract class. So what is the final implementation class? Linked list. So LL. So linked list. See the difference here. So how the difference is like how hierarchy is implemented, like so this is the hierarchy of the linked list. So once we know the hierarchy, so we can easily get the methods, which are the methods are available. If you are writing any application, it is easy to developing because so based application is developing the based on the methods only. So application is developed. If you are using the linked list, so once we are writing in linked list in the real-time IDs, like it is an Eclipse or any NetBeans, so you will get some idea. Oh, So these many methods are available in linked list. So each method is what purpose is this. Like we can easily get an idea. So this is the hierarchy of the linked list. So collection and abstract collection, abstract list and abstract sequential list and linked list. And in middle we have a one interface called so list interface. So this is the hierarchy of the linked list. So now we will see one more implementation class asset. Asset. So here, so here see the magic here asset. So asset extended from abstract set. So we have abstract set or not? Yes. So we have an abstract set. Yes. So the abstract set again is extended from see the abstract collection and the set interface. So is it directly extended from abstract collection. So abstract collection and implements set interface. So this is the abstract collection. Sorry, hash set implementation. So it is simple because the set interface does not have any the specific method. So whatever the methods are available in the collection interface, those methods are available in the set interface, right? So this is the collection interface, and abstract collection is an abstract class. Abstract collection is an abstract class, and here we can specify what is here. Here it is a set is an interface. Here set is an interface. So now we will see abstract set. See abstract set. Abstract set. What is an implementation class for hash set? What is an implementation? Hash set. So this is the hierarchy of the set. See, it is simple because in the last linked list is having number of classes, but whereas in high set it's having the less classes compared to linked list. Linked list, right? So, but if you see the hash set of implementation of hash set, so what are the methods are available? So directly we can say what are the methods are available in the collection. Those methods implementation available in asset because so the set interface does not have any methods. So we cannot specify the specific implementations, right? So if we have any methods that is specific to the asset object, like right. So this is the hierarchy of the like asset. So in the set interface, it is a one implementation class we can call it as. So this is the collection interface, abstract collection, abstract set, and a hash set. So we will see one more implementation class. We will see one more implementation class for linked hash set. Linked. So linked hash set is an one more implementation class. So this extended from abstract set. This extended from abstract set. So once we say the abstract set, so what is here abstract set having the abstract collection and the implementation of set interface, right? Now Again, do we need to write the hierarchy? Because in the hash set, in place of hash set, if we write the linked hash set, so remaining everything is same. Remaining everything is same because here it is an abstract set. Here it is an abstract collection, and this is in a collection, and where it is in a set interface, right? So this is the implementation, and this is the implementation, and this is the extents, and this is a extent. So extents, I am going to write e and I, and here also I. I means implementation. So E means extents. So this is the hierarchy of the linked hash set, which has a same. Just in place of hash set, we provided linked hash set. So there is no difference. So now we will see some. Now we will see queue related information. So what is the queue related information here? So priority queue. So priority queue is the implementation of queue interface, because yesterday we discussed the queue interface, right? So, and this priority queue extends from abstract queue, and this abstract queue extends from any. So this abstract queue extends from abstract collection and queue interface. Abstract collection and implements queue interface. So how we can write the hierarchy of the priority queue? Again, it's starting from collection. Again, it's starting from collection, and here it is an abstract collection, and here it is an abstract collection, and here so here, so what is here? Abstract queue. So it is main important. So because in abstract queue is playing a role call, it is one side is implementing queue interface, and one side is extending from abstract collection, and so this is the priority queue. So this is the priority queue, right? Because so this is the extents or implements. This is the implements here. So once we implement, we don't bother about it, because whatever the methods are available, we can see those methods. Here it is extends, right? Here it is extend, but here again it is implementing the abstract queue. Here again is implementing, because if we have the queue specific method, and so those methods handle available in the abstract queue class, and is extended from abstract collection, and whatever the methods are available in the abstract collections, those methods are also available in the abstract queue. So these all implementation done in priority queue class. So this is the important class, is because all the methods are we are implemented in priority queue. So this is the hierarchy of the priority queue. So some people they get, so what is the use of the priority queue? So once we completed this hierarchy structure, so now we will enter into the implementation classes. So there we will explain so what is the purpose, so we can use so the each implementation classes. As of now, just get an idea hierarchy of. So priority is completed, and So we will see one more class called for tree set. We missed in a set implementation. Tree set. So this is the one more implementation class we can call it as. So this also same extends from abstract set. These extend from abstract set. So this extend from abstract set. So and implement the. So once it is extend, we can observe. So it's a collection class and implement the set interface, right? So so the linked asset also extends. So one important class called asset. Asset. So I missed to tell this. So see, now we will get to some doubt. So the linked asset extend the two classes. Two classes? No. So what is the hierarchy here? So it extends the hash set. Again, asset extends the abstract set, and the abstract set extends the abstract collection and implement the set interface. So because in the multiple inheritance, so we cannot extend the more than one class. So that's the reason this is the hierarchy hash set, and the hash set is extended in the linked hash set. So now see the tree set difference. So tree set having the directly extend from abstract set only. Abstract set, and it is an abstract collection and set interface. So we see the all the hierarchy of collection classes. We complete the hierarchy of the collection classes. Now we will like move into the so implementation classes array list. So here we will see the first class called array list. So this is the implementation of abstract list and abstract collection and a list interface, we can call it as. So here so array list extends an abstract list and implement the list interface we observed, right? So how we can write the array list syntax here? Syntax. So this is the syntax of array list. So this is the syntax of array list. This is the way we can define an array list. Here, E specifies what E specifies here? Type of an object. So array list supports a dynamic. So dynamic arrays. Dynamic arrays. So what is the dynamic array? So if you see the like normal array. First we will see the normal array. So we need to specify some objects, like we need to specify some object. So this int array, this int array, so is going to create 50 objects. Is going to create 50 objects. But in real-time application, so we doesn't know how many. For example, this array array list use like this list is integer list integer array used to store the username, password, related information, or you can say username related information. So, can we identify in our application only the 50 users are going to interact, or more than 50 users are is going to interact? So we cannot say so how many users are going to interact in our application, right? So if you see the 50, because the 50 integer array is going to create it. If you have the more than 50 users, so they cannot store in an integer int array. So what is happening here? Again, we will get some exceptions and we will miss some user related information. So we will get some, like we will lose some important information, right? So for this concept, they introduced the in collection framework important concept called array list. So here what is showing here, based on our input, the array list is going to increase. So what if you insert the 1,000 number of or 2,000, so it's going to store because we have some, so like capacity. Once the capacity is reached, again is going to create a one more array list. So what is the capacity here? Means 0.76 ratio, we can call it that. So 0.76 means, so once 75% of the array list is complete, like stored or the full, then is going to create a one more array list, one more array list. So that is the purpose of array list, and that is it's one of the beautiful concept introduced in collection frameworks. So because, so we don't need to worry about the memory issues, because so in the integer array we need to know the before, we need to know before running an application how many users are going to interact. But whereas in array list, we don't bother about the, so we can give the application to the users, so they can like any number of users can use based on the, so 0.76 ratio. So just it is very important, because up to the 70% is array list is stored, like it is full, again then is going to create a new array list, like is going to increase the array list size, right? So this is the dynamic array. So that's one that can grow as needed. So what I said, so based on the our inputs is going to grow. So yeah, so first we observe the important like the purpose of array list we observed. So how we can create an array list? So how we can create an array list? So what are the, to create an object, to create an class object? So we need a new operator, right? New operator as well as some constructor, some constructors. So what is the new operator? This is the new operator, and what type of constructors are available on an array list? So this is the default constructor. So one more array list called collection. So we can specify the collection object. We can specify the collection object to create an array list, right? Collection object I am defining. So one more array list called int capacity. Int capacity. So these three are the constructors are available array list to create an array list object, right? So now we got an idea, right? So this is the default constructor, and we can specify the collection object, and we can specify the capacity. Now you got some doubt. So once we specify the capacity, so the do like the array list is going to increase once the capacity is reached. Yes, definitely, because so the ratio every time is going to create, every time is going to work. So why again the new array list is created? But when we are developing an application, if we assume so these many array list objects we require, so in that case the some people is given one constructors called int capacity. So we can specify the capacity. So how many objects we require. So that purpose the object is going to create. So these are the three constructors are available in array list concept. And we will see the internal uh, what we can call it as internal work of the array list constructor. Once we define our array list constructor, so what is going to happen internally? So what is going to happen internally? So here, so we will see some basic example. So how we can add and how we can delete an array list. Let me write a one different uh, program like language Java array list basic like first program. So how we can write a basic program. So class array list demo I am taking. Static void main string args. Right. So now we define the main method. Now what is the step we need to write? Here we need to create a array list. So here I am defining a one generic type called string I am defining. String I am defining. So here writing a reference variable of list, new array list, new array list. So this is the way I am creating a array list object. So first we will see the size of an array list. Uh, system dot out dot println array list size list dot. We have a size method or not? Right? We have a size method. So now first we will see the size. What is the size? Default size, right? So after that we are trying to store in some object to the in list of list dot add test one. List dot add. So what I'm doing here is test three. So these three objects I'm trying to store into the array list. So once we store, like see the size, see the size. Okay. Once we completed our size, once we completed like showing the size, so now we will remove an object so that we can observe the add and remove function how it's working. List dot remove. So we can specify the object. We can specify the object called test one. can specify the object called test1. Now after that, again we can print the size. Again print the size. So this is the basic example of array list. So this is a basic example of array list. So now what we can do? So where it's showing in Java, okay. So this is our location, cmd cd paste. So go to the okay Java C ArrayList demo.java. So okay. So we missed some error here. This is the purpose it's showing. Okay. Again compile. Hey, what is showing? Cannot find the symbol ArrayList. Oh, sorry. So so what is showing here? It is ArrayList cannot find the symbol because so these in the previous, if we run any program, so we did not find the class cannot find symbol. It's showing C class array list and the location array list demo. Are you able to see this? This is the information. So class array list in the location called array list demo. It's not available. It's not available. So what we need to do, because the collection frameworks is defined in different package. So what is the package here? So what is the package here? Import java.util. So this is the package called java.util. Java.util. So for this purpose, so this not showing the class is not available in the in our program. So now what I am doing here it is clean, again compile. Okay, see this is the node is showing. This is not a error. So this is not a error because this simply showing the node. So arrays demo use the unchecked or unsafe operations, right? So this is not a error. Run array list demo. So see the size, array list size basic is 0. Array list size basic is 0. We added 3 objects and we removed 1 object. So after that it is to 2, right? So this is the way the array list is going to work internally. So this is the way the array list is going to work. So now we observe add and remove method. See, add and we removed, sorry. Add and remove functionality is working as we expected, right? So now so we can get some like what we can call it as so arrays from array list. So we have a method, so we can get it from arrays from array list. So in the yesterday we observe like we see the method called toArray, right? ToArray, right? So how the objects are coming to the arrays to array list. So like we can define list dot toArray or string dot toArray. It's converted into string dot to array. If we define like this, so it's going to make string arr like is going to define. So this is the way we have a string object. So we need to convert into the string array. So for this purpose, we can go for a two array. So like we can define so string array like this and integer array and char array. So if you want to convert into the any array, so we can use the tube array function. Right. Now we will see some like iteration concept. Iteration concept means so we want to like get the output called one by one. We want to know the output one by one. For this, I am writing two more elements. 4, 5, 6, 7. I added. I'm trying to remove one object. It's fine. It's fine. Now we need to get the object. So one by one. So if you print first, we will print some object called. If you print list, ArrayList demo. Okay. So ArrayList demo. So test 2, 3, 4, 5, 6, 7. We got it right. So these are the 0, 7, and 6. These are the sizes and the objects. So whatever the object we added into the, we are printing on the console. 2, 3, 4, 5, 6, 7. Because the first is going to remove. We added. We are trying to remove, right? So so this is the way. But what I need to know. So we want to know, like get the object one by one because these objects are coming at a time. So we need to print one by one. So how we can print it? So this is the loops like I explained at starting point. So if you want to get one by one object, we need a loop, I said. So here the loop is using here. So we will see the loops concept, how the loops are going to work. So because string ARR, so this is the way we can define loops. This is the way we can define the loop. And ArrayList object, just remove all, define ARR. You can comment out this line, close. So now we will get it. So it's compiled successfully and execute. See, so the object is coming 2, 3, 4, 5, 6, 7. See, one by one it's coming. Whereas in our the previous example, so in our previous example, how it came. So in the single line it came, right? So but whereas in the loops concept, so we can get it the one by one object. So this is all about the array list concept. So this is all about the array list. So we have a three constructors and default size is 0. If you add then element is adding to the size. So like it is increasing the size. So this is all about the array list concept, right? Now, so in the tomorrow's video, I am trying to provide the linked list class. So because in array list we have a one like in the list interface we have one more class. So that is the linked list. So this is also one important class. So how the linked list is going to work. So tomorrow we will see. So and Please practice the array list concept today so that it is easy to write in any program using the list or collection frameworks.